right, recognizing transformations in their properties. So a blank is an operation that maps or moves the pre-image onto the image. That is a transformation. That is a transformation.
Why is it different from translation?
It is different from translation. A translation is a transformation.
Isn't
With
it
the
like,
one, with the fact you get it wrong.
Yeah, and it would be wrong if we confuse those two. Okay? A blank is a type of transformation that has a line that acts like a mirror
reflection?
or reflection. A reflection is a type of transformation that has a line that acts like a mirror. This line is called the, who remembers that from yesterday? What that line's called?
Y-axis.
It doesn't always have to be the y-axis. Sometimes it can be the x-axis, but what is
Center
it
of
called?
rotation.
Line of
Baldry?
Line, I heard somebody say it. Line of what?
Reflection.
Line of reflection. It is the line of reflection. That is what that x or y axis is called when it is the line that is reflected over. A blank is a type of transformation where a figure is rotated about a point.
Rotation.
Rotation. This point is called the
Center of rotation.
center of rotation. A blank is a type of transformation where every point is moved in the same direction, the same number of units.
Translation.
This is a translation. So a translation, reflection, and rotation are all types of transformations. Okay? In a transformation, the original figure is called the
Pre-image.
pre-image. And the new figure is called the
Image.
image. In a rigid transformation, the pre-image and image are congruent. Who knows what congruent means? Anybody know what congruent means?
They close like. Isn't that just like a shape that's closed? The same?
The same. The same. They are the same. They are equal. They are congruent. All of those words are interchangeable. Incongruent figures, the side lengths, the angle measures, and the distance between the points are the same.
Wait, so what is that called if like, whenever a shape is like open or closed? Transformation.
No, it's not. That was just a movement of shapes. I'm trying to think of what he's thinking about.
It's like a different like subject.
I'll find out. We'll talk about it in a little while. All right. If one shape can become another using only rotations, reflections, and/or translations, then the two shapes are congruent. To be congruent, I have to have the same shape, same size, and same angle measure. They have to be exactly the same to be congruent. If two shapes are similar, if you need to change the size of one shape to become the other. So, for similar, they have to be the same shape. I have to have the same angle measures. But it is a different size. Sorry. So same shape, same angle measure, different size. So congruent, same shape, same size, same angle measure. Similar, same shape, same angle measure, different size.
So when it says different size, smaller or bigger?
Yep, smaller or bigger.
And I know bigger would be like chain, but that's a different shape.
Yep, that's a different shape. All right, so let's look at our first example. What figures are congruent to figure A? Explain your reasoning. So figure A is the one I'm looking at. That's my pre-image. What figures are congruent to figure A? Is figure B congruent?
Yes.
Yes. Okay, so this is congruent.
It's just reflection.
It's a reflection.
But it's still the same size.
Still the same shape, same size. Okay? So we'll write that. Same shape, same size. Okay? What about C?
No.
It's similar.
It's similar.
It's the size.
It's larger, right?
Yeah.
It is larger than A. Okay? What about D?
Just rotate it.
It is congruent.
It just moved. It just rotated.
It's a rotation that took place. Okay, so this is to the same shape, size, and we're gonna add angle measure. Same shape, same size, same angle measure. Okay? Any questions?
No.
All right, let's look at number 1. Is everybody good on that one?
We should bring it.
A drink.
Like cool.
H2O.
Water.
You drink water from a cup.
I do. You don't drink water from a cup?
Drink it from.
You drink it from. That's kind of.
All right.
You drink it from the air.
Let's look at number 1.
You drink from the hose pipe.
All right, hey, listen up. Let's look at number 1. ABC is mapped onto WXYZ. Are the figures congruent or similar? These are congruent.
It's just what's it called? Yeah, reflection.
It is a reflection. So that's our answer to B. They are congruent. Describe a transformation that will prove your answer to part A, reflection. And it's reflecting across this line. I don't know what that line is, but
Y-axis looks like it.
this is my line of
Reflection.
reflection. Okay? All right, let's look at 2. I need you to listen. ABC is mapped onto figure A prime, B prime, C prime. Is angle A congruent to angle A prime?
No.
Yes.
Hold up. Hold up. Hold up. Is angle A, this is angle A,
This,
congruent to angle A prime?
yes.
Oh, yes.
Yes.
Yes, they're
Because
both what?
It just multiplied it by.
Wait, I'm just talking about an angle right now.
They're the same.
They're the same. They are both what?
Right angle, right angle.
They're both
degrees.
90 degree or right angles, right? So my answer to A,
Wait, but they're
Is-
different sizes.
my angles are the same. They're asking me for an angle. My angles are congruent. Angle A is congruent to angle A prime. Both right angles. Do we see that? They're both right angles. So that is what I mean by my angle measures will stay the same. Okay? So they are. They're both 90 degrees. just the angles.
I was expecting a trick question later
Okay.
on.
Are the triangles congruent or similar?
Similar.
My triangles are similar.
It just got smaller, the size.
The size, yeah. So triangle ABC is smaller, no,
It's big.
it's bigger. Is larger, let's say larger, than triangle A prime, B prime, C prime. Alright, what was your question?
So in terms of like angles, it's congruent, and in terms of like usually anything else, it's similar.
No.
No, my angles are congruent
I
in
know,
this
I-
triangle,
that's
yes.
what I said, in
But the
terms of-
triangle is similar,
Yeah,
if that's what you're saying, yes.
yeah.
Yeah. But even in a similar triangle, the angles are still congruent. Does that make sense? Okay. All right, let's look at figure 1. Figure 1 is mapped onto figure 2. Are those figures congruent or similar?
Congruent.
I have three.
They're congruent.
They look like reflection, congruent, and translucent.
Okay, describe a transformation that will prove your answer to part A. Why are they congruent? How are they congruent? What's happening here?
It all stays the same.
Okay, but what transformation is taking place?
Reflection.
Okay, does anybody see a different transformation that could take place here? Yes,
No.
relation.
Yeah.
Okay, this is why my points are so important.
Wait.
Wait, hold up. This is why my points are so important. Okay, what you want to say? Nothing. You want to wait? Okay. So, some of you said reflection. So if this was point A, and this is point A prime, absolutely that's a reflection, right? Okay, but what happens if this is point A prime?
Translation.
That's a translation.
Yeah.
Do we see why the points are important?
Yeah.
But it didn't show us any points.
So, but if they don't show us any points,
Just right.
both of those could be correct. So it could be a reflection
So,
or, not both, it's not both, it's a reflection or a translation. Okay, so what?
It can.
so on a test, if we put either one of these, they would be right?
That's
Or would
correct.
it be like,
Yeah.
state both?
No, either one would be correct. Yes, yes.
So you can. Never mind.
Sure?
You can go. Yeah.
So.
Are you sure? Because look, do you not understand how it's one?
No, I do. I just didn't know if you could like go across the y-axis.
Oh, absolutely, absolutely. We will be going across both of them sometimes, both the Y and the X.
If they
Oh,
put, if
so
they,
it'll go like on an angle like that way.
Yes.
so if they put like, the points,
Now, if,
it'll be something.
It would be translation.
no, it would still be congruent.
Similar is only if it gets smaller.
If it gets smaller or bigger. So here, now, to go back on the question about on a test, if you need to have both, or, and I said either or. If they have points, you should only have one. Do we understand that?
And it would be reflection.
Well, it could be either
It
one.
would be translation.
It just depends what kind of points they have,
Mhm.
okay? But if they have points, you should know how the figure moves based on the points, okay? All right, let's look at the next page. This is what you're gonna be doing by yourself. So that's pretty much the lesson for today, okay?
That's it?
So, yes, but I'm gonna explain what we're gonna do next.
Wait, if